Okay, so now we want to start talking about objects. I'll actually throw it up here.
I thought we were on characters.
Well, I am.
I just wrote down characters.
We're talking about character. That's an object.
All right, go ahead.
Remember, I had the word character,
Yeah.
not char.
Right.
Something different. Okay, so objects, object type variables, as opposed to primitive type variables. Last time we talked about primitive type variables. What's a primitive type variable?
Char, long,
Those are examples of them. What are they?
built in the language
And
can hold the value.
only hold a value. So primitive type variables are built into the language. You can only hold a value, whereas object type variables may be built into the language. We can also create our own object types, which we'll end up doing in here at some point. They can hold a value. They can hold more than one value, and they can potentially do more. So they can do a bunch of extra crap. Okay? So they're more powerful. Now, to look at our first object type, we're going to look at the character class. I told you we were going to do it.
I thought you were going to type something under objects.
All right, so now write this down, and then I'll change it.
Killing trees.
Over one
Thank
word.
you. Yes, I like to have it.
Wow.
Be glad I didn't do it twice.
Okay, so character class. Let's say I want you to write the code to take my char C here and give me the uppercase version of it, using only what you know right now. So how do I make a lowercase a into an uppercase a?
1 plus, because we know the place for a
32.
1.
Okay, you're saying add 32. Well, why don't we start off by saying char D is equal to an uppercase A. Print out the int version of C, and let's print out the int version of D. Let's see what those Unicode values are. $97 is the lowercase, 65 is the uppercase. So minus 32. The char version of the integer version of C minus 32. So this will boil down to a number, right? In this case, 65. Turn that back into a char. Now we should be able to print out E. Oh, except I'm printing out the int version of it. We only need to print out E, the actual value of E, which is capital A. Make sense?
Yep.
Okay, so we were just doing Unicode math and crap like that. Do you think it might be helpful to be able to convert a character to uppercase or to lowercase?
Yeah.
So, if you have a letter that's different than A, wouldn't you have to subtract that letter integer from itself and minus 32?
Not to go from lowercase to uppercase, because if you took B, whatever the if you took what is it, 98 minus 32, you get the uppercase B.
Oh, okay. I'm thinking too much here.
All right, so I create my char c set equal to lowercase a. Then I create a variable of type char called d, and I set it equal to whatever's returned by calling this toUpperCase method from the character class on C. So I'm passing it a lowercase a, and it's spitting out an uppercase a. Now notice, what will C be if I print out C? Will it be an uppercase a or a lowercase a?
So
Still lowercase. So sending it into this factory does not actually modify C. It takes C in as input and then does something to it, and then the answer spits out the back and we capture it here inside of another variable. So C will still be a lowercase a. Make sense?
They work with string also.
Well, we don't know about strings yet.
Not this one. I mean, there is another one for string.
We don't know.
How do you
that
know?
range yet.
I asked.
I'll talk about strings soon.
Okay.
Soon. So, we have these things called methods. We talked about methods at all last time?
A little bit.
yeah,
Okay, what's a method?
A method.
We didn't write them though, did we? Did we write a method?
So,
I just talked about the high level.
yep. Method is a
Reusable
reusable
chunk code.
chunk of code.
Okay? Methods are reusable chunk of code. So you know what methods are, but you haven't seen one yet, correct?
That's me. That's what
Just the main method. Okay.
Yeah.
Got it. So we have this thing called the character class. So character is a class built into the Java language. That's what the character class is. It is filled up with methods. For operating on chars. For example, it has a method called toUpperCase, which takes a char as a parameter and returns the uppercase version of that char as a char. And that's the one we just saw. We just saw that guy in action. So back in here, we see we called upon that method. Somehow. We'll talk about why we called it this way in a second. But we called upon that method, passing it a character as a parameter, and captured the result inside of another char. And we saw that it gave us the uppercase version of that guy. That make sense? All right, so now I'm going to show you in the Java documentation what this guy looks like. Okay, so now we're going to start looking at documented things versus things that I told you. So I'm going to go to a web browser. I'm going to go to java.sun.com. Under technologies over here on the right, I'm going to hit Java SE. Then under Java resources over here to the right, I'm going to hit Java APIs. And then under standard editions, I'll hit Java SE7. All right, so this is Java documentation. Let me see that a little bit better. So up here in the upper left-hand corner is all of the packages that exist in Java. The one we're going to look at right now is the one that's automatically built into the language called java.lang. All right, so this is all the crap that you automatically have access to in Java without doing anything special. And we see we have something in here called character. And I'm going to scroll down here till we get to toUpperCase method. Okay, here it is right here. So, name of the method is toUpperCase, over here on the right. It takes a char as a parameter. What is it? And then underneath it says what he does. This converts the character argument to uppercase using case mapping information from the Unicode data file. Whatever. Okay. Over here on the left this is what its return type is. This guy boils down to a char. But now we have another familiar word that we didn't know what it meant before. That is the word static. Remember, it was there in our main method.
Static void.
Right there. So main is a method that returns nothing, because it's void, and it's static, whatever the heck that means.
Stays the same.
Now, in the documentation, the toUpperCase method is named toUpperCase, it returns a char, and it's also static. So the main method's name is main, it returns void, and it's static. This guy's name is toUpperCase, it returns a char, and it's static. Main takes a string array as a parameter, this guy takes a char as a parameter, as input. Make sense? So now let's talk about what static means. Static keyword. Used to identify a method as a class method at the time when the method is being defined. Note that static would never appear when a method is being used. So there's two different ways that we can experience methods in Java. We can define methods, which would be reusable chunks of code that have not been reused or have not been used for the first time. Okay, so we're writing in an ability that we may use in the future. That would be method definition, when we're actually creating the method initially. Then we have the points in time where we're actually using the methods. We're calling upon that reusable chunk of code. The only time we would ever see the static keyword is only during method definition for methods that are class methods, whatever that means. Okay, we'll talk about that here in a second. Okay, but we're only looking out for the static keyword at the time that a method is being defined. For example, here in our code, I'm almost positive I pushed it. This is our method definition of main. This is where I'm calling upon the toUpperCase method. So notice I did not use the word static anywhere in here. Yet when we saw the documentation, the word static is clearly there. This is the method header from the method definition of toUpperCase. This gives us everything we need to know to be able to call toUpperCase. We don't need to know all the details of how it was written. We just need to know that it was written and this is how it works. That make sense? So all this stuff we have right here, specifically this top line, tells us everything we need to know in order to call this class, or to call this method. So when we see the word Let's go back in here. Class methods. Are defined with the static keyword, are called using the name of the class in which the method was defined. So as of right now, that's what we're going to say class methods are. They are defined with the static keyword, and they're called using the name of the class in which the method was defined. As opposed to an instance method. So the other kind of method is an instance method. These are defined without the static keyword and are called using an instance of the class in which the method was defined.
Sounded like Santa.
Okay, so now at no point have we talked about why one might make a class method versus an instance method. And we're not going to talk about that yet. We will, but we're not equipped to talk about that yet. So for right now, we just need to understand there are two different kinds of methods. They exist for some reason. The way we could tell them apart at the method definition time is whether or not the word static is there. And that tells us how we call it. Okay? So, the two uppercase method from the character class was defined as a static method, right? Which means that it is a class method. As such, class methods are called using the name of the class in which the method was defined. So the two uppercase method was defined within the character class. Therefore, since it was a static method, we call it using the name of the character class, followed by a dot, followed by the name of the method, and then pass in any parameters. So again, notice that we are in the class character here. And way down here, we have our two uppercase method defined inside this class. Specifically, it's a static method, which makes it a class method. Okay? Now, why does the character class exist?
To help us program
Oh,
effectively.
There is really only one right answer to this. There are some answers that are less dumb than other answers. Why does the character class exist? Keeping in mind that you only know a very little bit about it. But do you think that there's probably a 2 lowercase if there's a 2 uppercase?
Mm-hmm.
There is.
Just we are deal with the like characters. It's not like the uppercase and lowercase. Just more than this. Compared between two things, like to see the names compatible with another names, doing some methods of the string.
Okay, so starting point is that we might want to do things to chars.
Yeah.
Right? Well, why can't chars do things to themselves?
That doesn't sound right. They're limited.
What's a char? How are they limited? And why are they limited?
They're limited because they only go up to Well, that's a good question. Let me get back to that answer.
We can deal with the binary, we can char on size, as you
What's a char?
It is a 16-bit whole unsigned whole number.
Okay, go one more level of abstraction up. What's a char? It's one of our what kinds of variables?
Primitive.
One of our primitive types. What's a primitive type?
A primitive type can only hold a variable
Built into language can only hold a value.
value.
Can only hold a value. Can only hold a value. Can only hold a value. Can only hold a value.
That's
said.
the reason why it's limited. Boom.
Okay. Why do we need the character class to operate on chars? Because chars can't do anything other than hold a value. We have to provide this extra factory that we can ship chars into and have things happen to them. Horrible, horrible things. Like converting them into grown-ups immediately. Okay, so that's why the character class exists. I think you will find that we have classes for booleans, for bytes, for characters, for doubles, for floats, for integers, for longs. So we have similar type of objects for dealing with special cases for all of our primitive types. Make sense?
Yeah.
Okay. Now we saw that we could do something with our previous knowledge to convert a character into uppercase. Correct?
Yeah.
All right. Well, let's look at defining some methods. Method syntax. For right now, every single method that we write will start off with the word static. Because we're going to be writing class methods right now because we don't know any better. Just leave it at that for right now. So for our intents and purposes, this exact moment, every one of our methods starts with the word static. Next thing is the return type. Method name. Parameters. Inside parentheses. Open and closing curly brace. So now, we're going to write a method. Here's our class. Classes are like giant garbage bags, where the one opening is the opening curly brace, the other opening, the other side of the bag is the closing curly brace. Everything that goes inside of the class goes between those opening and closing curly braces. So we have one thing in here, which is main. I'm going to put a second method in here. I'm going to say static char. Oh, hello.
We make it public.
You could have. It didn't matter.
Okay.
I'm just trying to stick to the syntax I was telling you to use. Just start with static. To uppercase char C. So we're going to write our own version of this method. Why? You know what? I don't really feel like using some second-rate character class that already wrote this crap for us. We should write it ourselves. Feel like real programmers, right? We should reinvent the wheel.
Yes.
I like it.
Okay.
We're go-getters.
Okay. We're go-getters. So we're going to write our own to uppercase method that takes a character as a parameter and will return a char. The char it should return is the uppercase version of the character I pass it. Now, what kind of value can I pass to this guy?
A char.
Anything that's a char. Are all chars letters?
No, it can be a number.
It could be all sorts of crap, right?
Yeah.
So what does it mean if I try to convert a comma to uppercase?
It won't.
Should just boil down to the comma.
Mm-hmm.
don't do stuff to things that aren't uppercaseable. See, my new word for today. Last time it was mathable.
Yeah, that's true.
Mathable. Now I have uppercaseable.
You should make a dictionary.
I should.
Littman's
If
dictionary.
it's not uppercaseable, this guy should just spit it back out as whatever it was. Okay? So, I need to make sure that I only uppercaseable chars.
Uppercase. Okay.
Legit enough. So how do I find out if the char that was passed in was not an uppercaseable value?
So if it's not between 97 and
Okay, I'm going to ask a question. It's not between what?
97 and 122.
122?
Yeah.
Okay. So I'm going to ask a question. I'm going to say if C is what? How about greater than or equal to A?
Yeah.
And C is less than or equal to Z. If that's true, what's true about C?
You can uppercase.
It's
that.
uppercaseable.
Yeah.
If I am inside this if statement, C is uppercaseable.
You're not doing anything.
So I have to do something to it. It
Yes.
is uppercaseable.
Mhm.
I should be able to convert it to uppercase if I'm inside this if statement.
So you can do the C minus the 32.
Else, just return whatever C is. So if I get into this else, that means they passed me a char that was not uppercaseable, so I'm just going to pass it back.
Right.
Here's your answer. It is a unchanged input. So I'm only going to actually do something to it if I get inside this if statement. And how do I make a char uppercaseable?
Minus 32.
Subtract 32 from it?
Yeah.
Okay. So I'm going to char temp is equal to the character version of the integer version of C minus 32,
Boom.
and then return temp. And I could have actually just returned this value. I didn't need to store it in temp, but we'll store it anyways. Okay, so I'm returning a char here called temp because this guy expects me to return a char. If I don't get into this if statement, I'm still returning a char down here. So I'm guaranteed to return a char here, right?
Yeah.
Okay. Name of the method is 2 uppercase. Input takes a single character, returns a char. It's a class method. How do you know it's a class method?
Static.
Because I see a static at the time of definition. Okay. So now, help me print out the uppercase version of C.
The name of the
Dot 2 uppercase. Or hello dot 2 uppercase.
Hello dot
2 uppercase.
2 uppercase and then pass it C.
Yeah.
Now why did you say hello dot 2 uppercase instead of character dot 2 uppercase?
Because the class is hello.
We wrote the class method right here. It's a class method because it has static. How do we call class methods? We call them using the name of the class in which the method was defined. The name of this class is called hello. So I defined this class method inside of a class called hello. So I'll say hello dot 2 uppercase and pass it my C. And let's see if this guy works. There's my uppercase A. What if I pass it a lowercase f?
Yeah, do your uppercase.
There's my uppercase f. What if I pass it a question mark?
It'll give you a question
Yeah.
mark.
Should give me a question mark. Make sense?
Yes, sir.
Okay. So we just wrote our own 2 uppercase method. See, who needed that built-in crap? Right?
Not us.
Yeah, not us. This is way better. This is way more better. This is almost most bestest.
Always time.
We're gonna add that to Litman's dictionary.
Very good question.
Yep.
Can we check the validity of C at the static method here when we input the char C there? I mean, not after check if else, just check the validity of C when in the parentheses.
You mean here?
No, beginning, at the very beginning, yeah.
Oh,
No,
up here?
To the uppercase,
Okay.
yeah, just after here. Can we check the validity here?
No.
No?
No, this is an input. This is saying we have a method called toUpperCase, and
No,
he
I'm
requires
going-
this.
going- yeah, in this. Can we check it here?
Yeah, what I'm saying is this is just what he requires. This isn't logic. What goes in here is not logic. This just says what are the inputs? What does he need?
It cannot be checked.
Yeah, we cannot write logic in here.
But,
This is only variables.
but in C sharp, it can check.
That you can't check up there in C sharp.
I did that.
You have to show me.
Yeah, because it's kind of convention that we always check the validity of the input when we use the method at the very beginning, not use it.
You have to show me how you're checking. C Sharp has a couple of things, so does Java, where you can I'm trying to think if I was going to do that in C Sharp inside the parameter list. I don't think you can do it. So if you have code, show it to me. I'd like to see it, but I don't think you can do it there. So I wonder if it's not happening in a method; it's happening someplace.
It's not a very complicated logic. It's kind of simple logic. Because the if else is also very simple. Done there.
Yeah, well, so there is a way you can do this in C where you can say, I think char is equal to A or something like that. So what you can do is you can say, if they don't pass in a character there, this is what the default value is. So you can define defaults. You can't do that in Java. But you can define default values in C and C++, but I don't,
Yeah, and you can also check like that.
I'd want to see it.
Yeah, like
Not that I'm aware of.
Yeah.
Yeah. So I'll give you extra credit if you can show me that working.
A plus.
Yeah.
Huh?
I'd be pretty interested.
Okay.
I've written a lot of code, and I can't come up with an example of when you can validate in the parameter list of a method. So I wonder if you're thinking about something different than the parameter list of a method.
Okay.
So I'd be interested to see it. And just ask my wife. I'm very rarely wrong. I don't think she'd agree with that.
I don't think she would either.
What was I doing? Oh, so we wrote this toUpperCase method.
I'm doing uppercaseables.
No harm, no foul. Okay. So that's the character class. Let's look at the string class. Strings are really, really, really important. Okay, in Java, I say Java is a string-based language. Generally, this means that if you can get something as a string, you can do nearly anything with it. Strings are very flexible, very pliable, malleable. Oh, that's a good word, malleable.
I haven't heard that one in a while.
That's a good one. Okay. Strings look like this. Double quote, followed by a bunch of characters, followed by a double quote. That's what a string looks like. So you can have spaces in here, you can just bang on the keys, whatever. But it's contained within double quotes.
What
All
if
right.
you want to concatenate two strings in a printout?
We don't know what concatenation is yet,
Okay.
but we will soon.
Okay. Just like we didn't know about strings yet.
Right.
Gotcha.
All right, so that's what a string looks like. Let's go look up our string in documentation. It's also in java.lang. So here's our string class. We'll scroll down here. Right here, we have a method called toUpperCase. What can you tell me about that method?
It's not static.
Not static, which means it's what kind of method?
It is
An
a instant.
An instance method. So we're looking at the method definition here. It's an instance method because we do not see the word static there. It returns a string, and the name of the method is toUpperCase. And it requires no inputs. That's kind of an interesting aspect here. See this in action? How do I call instance methods?
By the name.
Just by. Hold up.
I call class methods using the name of the class in which the method was defined. How do I call instance methods?
The instance of the
Instance.
class.
Using an instance of the class in which the method was defined.
Gotcha. Okay.
So I'll get hello and all uppercase.
Interesting.
Now, what's S?
The string variable.
It's a variable. Okay, what's a variable?
Variable holds a value.
It's a value. What kind of value does this variable hold?
String.
Hello.
Hello.
I tricked you.
Thanks.
S is a variable. Variables do hold values. And I promise you that S does hold a value. But the value that S holds is not a string.
It's hello.
No, the string that S ultimately can get to holds hello. But S does not hold a string. S is a object. Okay? Objects are complicated. How many of you have ever heard of something called a pointer?
Only from you. When you said something about Java
As the
pointers.
address of.
Okay? Pointers are primitive type variables that hold a memory address, right? S, well, a string like S. S is a variable that holds a value. The value it holds is a memory address, which points to a place in memory where a string actually lives. And that's where the actual string is. That's where hello is up in memory. So to kind of,
A pointer holds a
I'll show you, I'll draw pictures, pretty pictures.
yay. But I want to remember what you said too.
String S is equal to hello. So that's S. Let's just say S is memory address 100. somewhere up in memory, we have bucket 100 in memory. So S is a variable that holds a value. The value it holds is a memory address, which points into memory to where the actual string lives.
Slow that down and repeat. Rewind and
Here's S. S is a variable.
okay.
Variable holds a value. The value it holds is 100 in this case. I just made it up a memory address.
Okay.
Okay? That memory address points, that's why I drew the arrow, points into your system's memory where that string actually lives.
How can we define the pointer?
I just said it.
I understand. But
Here,
I
here.
need a definition also.
This is. We're going to talk about it in real life, because you all know what a pointer is.
Yeah, I understand.
You use it all the time. Okay.
Like our real
We all.
address.
So you all live somewhere, right? You have a house or an apartment, something like that, right?
Cardboard box.
Okay, cardboard box, whatever it is.
Just don't need that one.
If you were inviting me to a party, do you give me the address where you live, or do you hand me your apartment?
Yeah,
Why?
Because that's where I live.
impossible.
No, you live in that apartment. Why wouldn't you hand me the apartment? You don't live at an address. You do live at an address. You don't
Yes.
live in an address.
No.
You live in an apartment
At
or in a
that
house.
address.
So
Because-
what? Wouldn't it be more convenient for you? I mean, why should I have to drive? Why don't you just hand me the apartment and tell me to open the door at 8?
Because it's static.
No, we're talking real life. Real life here. Why don't you hand me your apartment?
It doesn't make sense.
Because my apartment is mine.
Because your arms would snap off. You can't hand people apartments. They're too heavy. It doesn't make any sense. Right? You could tell me where to find your apartment. That makes sense. You could write that on a little piece of paper or text it to me or something, right? So the address to your apartment is this little tiny piece of information. The apartment itself is this big, 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 big piece of information. We should think of objects as being like those big pieces of information. Some objects are bigger than other objects. So for instance, I might have a baseball, or is it called a cricket ball? Is it a ball in cricket?
Yeah.
My cricket player's not even paying attention.
Let's go.
Hello?
Is he playing video games
Yeah.
back there?
Yeah, he is.
Here.
Cricket. Is it called ball?
Oh, you play cricket. Not
It's
him?
called ball.
Yeah, it's a ball.
Cricket ball. Okay, so they're little, right? Cricket balls are little.
Yeah.
So I can hand you a cricket ball. That wouldn't be like stupid, right? But could I also go and hide the cricket ball someplace and tell you where to find it?
Yeah.
That would work too.
Yeah.
Okay, so think of that. That's kind of how object-oriented programming works. We should think of all objects as being sort of kind of big. You know, that we might prefer to give people the address to, rather than give them the actual apartment or the actual cricket ball. Okay? So what's a pointer? A pointer is just like you writing down your address to your apartment. It's the same thing, it just sounds scarier. So a pointer is the address to an object in memory. That's what it is. A pointer is a variable which holds an address to an object in memory.
If the value information is incorrect, then it is a null pointer or insufficient.
Well, I mean, what do you mean by incorrect? Like if you gave me a bad address because you don't like me?
No, like insufficient like address. If I give you like just the zip code, then it's an
Okay, well, in other languages that would make sense. In Java, it doesn't. Because Java doesn't allow us to actually represent memory. It exists. You know, Java books, I think I probably mentioned this last time, Java books say Java doesn't have pointers. When the reality is Java doesn't have a special syntax for pointers because in Java everything's a pointer. So since there's no special syntax, it's easy to think pointers don't exist. When the reality is since everything's a pointer, they only exist. That's the only kind of thing that exists in Java is pointers. Everything that acts like it's not a pointer is a special case, as opposed to the other way around. All right, that makes sense with pointers?
Yep.
Can I say the pointer is as object as type?
Say one more time.
Pointer, I consider the pointer as like object type, not like pointer type.
No. I would say that's not true. What's a primitive type?
So holds a value.
Only holds a value. What's a pointer?
Holds a value.
Just a value. Just the value. So if we stored a pointer in an object type, it would be an awful big waste of space. Because objects are more flexible, more malleable. Where pointers, they just hold a value.
Because you said the CS is the object.
Well, it points to where an object is in memory. Points to where an object is in memory. The pointer itself is a memory address. We only say it points to it, just like if he wrote down the address to his apartment, that address points to where his apartment is. I can use that address to ultimately get myself to his apartment. Does that make sense? That's why we call it a pointer, because it points to that location. All right. So, that's how we convert a string to uppercase. S is an index, or I'm sorry, S must be an instance of the string class. If it wasn't, we wouldn't be able to call instance methods defined in the string class with it, correct? Well, what's S? S is a variable which holds a value. Value might look like this, a pointer, which points into memory, which ultimately is an instance of the string class. That is the instance of the string class, what I have highlighted there. That's the actual instance. S just ultimately resolves to that instance. Char@. method. Let's go back to the documentation here. Scroll up a little bit. So we're going to learn about a couple of our go-to methods in strings. So right here, here's the char@. method. Class method or instance method?
It is a
Instance.
instant.
Instance method, how do you know?
No static.
No static, okay. Name of the method is?
Char.
What does it take as a parameter?
Index.
Integer.
Integer.
An integer that it happened to name index, but it could have called it whatever what. But it's an int. What does it return? A char. This guy returns the char value at the specified index. What are strings? Strings look like this. Oh, hello. All that is very upsetting. That the new version of Numbers does not work, or the new version of Keynote doesn't work like the old one did. I used to be able to highlight a box like this, paste it once, like right next to it, and then keep pasting, and it would just keep going in line.
Oh. I guess it doesn't like this anymore.
Setting. I used to use that all the time. Okay. So here's S. S ultimately boils down to the string hello, Hello. So that string in memory would be stored something like this. Hello like this. H is at bucket 0, E is at bucket 1, L is at bucket 2, the other L is at bucket 3, and the O is at bucket 4. So there are 5 total characters in hello. Yet the legal buckets, the legal indices, are 0 to 4. That make sense? You'll see that there's also a length method. Class method or instance method?
That is an instant.
Instance method, how do you know?
No
No
static.
No static. What's the name of it?
Blank.
What does it return?
Nothing.
Integer. What does it take?
Nothing.
Nothing. And this returns the length of this string. So if I print out s dot length, this will give me a 5. The number of characters in S. The legal buckets are 0 through 4.
Why 5? Why not 4?
1, 2, 3, 4, 5.
You said 0. We should begin with 0.
No.
1, 2, 3, 4, 5 is the length of S. There are 5 characters in S. There are not 4 characters in S. They're just indexed 0 through 4.
Okay.
So there are 5 characters here, so the length of this guy is 5. But the buckets are 0, 1, 2, 3, and 4. So as if I use the char at method and I want to get the first character, I would say give me 0, which would give me the H. If I want the last character, I'd say give me 4, which would give me the O. Asking for character at 5 would give me an array index out of bounds error. I walked off the end of the string. All right.
Zero is an H.
Okay, so we got 5 characters, HELLO. That's how we access those. So the char at method allows us to retrieve a character at a specific place in a string, or from a specific place in a string. Notice it's read only, retrieve only. We can't actually change the character at a particular bucket using the char at method. I can't do something like this. S.char at 0 is equal to B or something like that. Hoping to change my string to now be bellow. Okay, doesn't work that way. Why? Because this guy right here boils down to an H. So what I really wrote there is H equals B. Here I go trying to change the alphabet. That makes sense? Why that doesn't work? Okay, so the char at method only allows us to get a copy of a character from a specific bucket. Okay, everybody understand the char at method and the length method? Makes pretty good sense. How would I write some code that displays, actually here, let me ask you this way. Do we understand methods?
Yeah.
Do we understand charat method and the length method of strings. Okay. What if I wanted to write a method called display string? So it's going to be void. I'm not going to return anything. I'm going to be displaying some stuff. And it's going to be called display string. This guy's going to take a string s as a parameter. And what I wanted to do is I wanted to display all of the characters in s. One at a time. So it'll just print out s. I want to go through and display. If s was hello, I want to say h, e, l, l, o. If it was elephant, e, l, e, p, h, so on and so forth.
Gotcha.
So I want this to be a generic method that takes in any string and displays the contents of that string one character at a time.
You can.
First one,
Go ahead.
check the length
Okay.
for loop.
Well, what's the length of s?
First, you
Like
have
S
to.
dot length.
S dot length is the length of s.
Yeah.
Okay. I will trick you with that question many times in the future. So I just asked, what is the length of s? Our natural non-programming inclination is to say, well, we don't know what s is. Sure you do. You know that s holds a value. And you know that that value's length is s dot length. That make sense?
Yes.
Okay, so we're going to get s's length. And what am I going to do with it?
For loop
Create a for loop. I is less than s dot length. I plus plus.
Yep.
Okay, what am I going to do each time?
print I. S dot
No. S.
like
No.
char I.
S dot char at I. Make sense?
Yep.
So this loop goes from bucket 0, well, takes I on a journey from 0 to s dot length minus 1. And then we happen to use that value of I in conjunction with the char at method to get the character at bucket 0, character at bucket 1, character at bucket 2, character at bucket length minus 1. Printing each one out. All right? How do I call this method?
But then
Hello.
name of the
It's a
method of the
You do.
Name of the class. What's the name of the
hello
class? Hello?
Dot display string.
We'll pass it hello. And then we'll call it a second time, passing it elephant.
Hello, Allison.
Make sense?
Yep.
What will this print out?
hello,
E.
hello, hello, E. E, E.
Didn't I need a variable here? Didn't I need to say something like s dot char at 1?
can like long
Or you can
Hello.
do
So
hello as the what?
string s is equal to hello system.out.println s dot char at 1. So this versus this, what's going to be the difference?
The second one will print E only.
Okay, second one prints E.
The first one is hello
And
and
then
E.
I don't even think it'll print the E after that. Well, never mind.
Again, only what you know so far.
Well, we didn't put the class in front of the char at.
What class?
Well,
Who wrote char at? Where's char at written?
in an instance, it's S.
Here's the char at method,
Right.
right here. This is written inside of what class?
The string.
What kind of method is it? Class method or instance method?
Instance.
How do you know?
Because no static is
No static. How do we call instance methods?
S. Well, yeah. The
How do we call instance
The
methods?
strings.
The name of the instance.
Using an instance of the class in which the method was defined. So we need an instance of the string class.
right.
What's this line going to print?
Just hello. Or is one print anything?
Same E.
So you think E, you think either hello or it's not going to print anything.
Right.
Any other gamblers in here?
I wouldn't go that far as to saying I'm a gambler. But
Well, but you're willing to risk your entire grade on this one answer.
not my grade is solid at an A.
You're-
Remember, you already
Hey, you're the one who keeps opening their mouth.
you want participation,
You're-
right? Okay, then fine. I'll be quiet.
Like, I didn't make the rules here.
You should have. It's your class.
What's going to print out? You say E. You say
I ain't
Hello.
Say nothing.
you say hello followed by either nothing or possibly nothing at all.
I didn't say anything.
What else?
Don't put words in my mouth.
Both E.
Hmm?
Both are E. E and
E,
E. E.
You think
Double
E? You think double E?
E, E.
Yeah.
Why?
Because S is the same as hello.
You mean
is
hello?
also a E.
Oh, I got you. So you think this will print out E and then this line will print out E. So it'll
Yeah.
be E then E.
Yeah.
Okay, I got you. Sure. That is what will print out. It'll be EE. Why? Why did this line work? What is char at?
It's a method.
It's a method. What kind of method?
And it's,
Instance.
Instance method. Written in which class?
Inst-
and it's hello.
Hello class.
String.
String class.
Yeah.
How do we call instance methods from the string class?
You call it instance.
Like the string, the method.
We call them using an instance of the string class.
Yeah.
What's an instance of the string class? Isn't S
Yeah.
an instance of the string class here?
Yeah.
Well, that one's right. We were concerned about that one.
Am I calling this guy with an instance of the string class?
Yes.
Yeah, but you said that the instance of the string class. I mean, you said the string class after you did the print line. You did the S equaling hello.
This will still print out an E.
So the hello is taking the hello as the instance of the string class.
Does that seem right to you?
No, not really, but it seemed like that's
Why
what it's
doesn't it
doing.
seem right to you?
Because it seemed like you would set the hello to a variable first. The S
Okay, what's a variable?
variable holds a value.
Holds a value. What kind of value? If I said string S equals hello, what kind of value would S hold?
String. Instance. No.
Hello here is just a substantiation.
It would be a pointer.
Substantiated.
This kind of thing, right?
Uh-huh.
What's the actual instance of the string class?
100.
That guy. That is what an instance of the string class looks like. Like that. That's the actual instance. If I store hello inside of a variable named S, I ultimately resolve to that instance. I say S is a variable which holds a value, which is a memory address, which points to a place in memory which actually holds the instance of the string class. Or I can cut through all the red tape and just say, here is an instance of the string class. Have at it. Does that make sense?
Yeah.
You don't need a variable to have an instance of the string class. In fact, this is less work. Because ultimately, S boiled down to that. After all the traveling through space and converting between memory and flying into memory to the final location and saying, I found my instance. And then using it to call something. Ultimately, this is what it did. Okay. let me quickly. Need to check to see what your assignment is, so I make sure I give you everything that you need to do it.
Did you have to go to Angel for that?
Hmm?
Didn't you have to go to Angel? For
Yeah,
that?
but this takes me to Angel.
Oh yeah,
This is like the.
but you were just at Angel and you closed it.
Yeah, it logs me in funny
Oh,
with faculty accounts.
gotcha. I'm done asking questions.
If I remember correctly, these are some pretty nasty questions. Which are the best kind.
No.
5.
What's up with the random number steps you got going on there?
What do you mean?
Step 3. There, we didn't have step 1 and 2. You just went to straight 3 and 8 and 7.
Really?
Yeah.
I'm going to test you on that. Let's see. Step 1, do this. Step 2, do this. Step 3, do this. Step 4, do this. Step 5, step 6, 6, 7, step 8. In Unit 1.
The 5 and 6 don't show up that much. But okay, go ahead.
Oh, what didn't?
Never mind. Go ahead. You may proceed.
Oh, I didn't unlink these?
I don't think so.
Oh, that's probably because I uploaded the YouTube videos. Because I decided these were, I couldn't upload them. That was what the problem was.
Gotcha. I thought you were like going crazy with
No.
your numbering system.
That makes sense.
Okay.
Alright, so let's see. Okay. So, let's say we want to write a method. Called print reverse. It takes a string as a parameter and it prints the string in reverse.
Need parameter.
It has a parameter right here.
I mean, unit number. Five,
Well, generally speaking, how would I solve this problem? How many characters are in S?
It's not.
S dot length number of characters, right? What's the last legal position in S?
Whatever that
Minus
period.
1.
S dot length minus 1. The last legal bucket in S is S dot length minus 1. What's the first bucket of S?
0.
0. So what's the first letter that I want to print out if I'm printing out a string in reverse?
Length minus 1.
Okay. What's the second letter I want to print out if I'm printing out in reverse?
Minus
1
2.
minus 2.
Okay. So I need to create a loop that goes backwards, right? For int I equals what? I want to start at the last legal bucket in S.
S dot
Dot.
length.
S dot
Minus
length minus 1.
And I want to keep going as long as I is what?
0.
0. Not equal to 0.
Greater than or equal to 0. And each time through I want to do what with I?
Minus 1.
Subtract 1 from it. And each time through I'm going to print out s.char at I.
Add 1 parenthesis.
What is it complaining about here?
I want you to change it to print instead of print line.
Oh, ha 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 ha. I'm always testing you. Why is it yelling?
Because I want you to change the print instead of print line.
What it wants me to do is it wants me,
To put all of it in quotations.
no?
Put it in a variable first.
Wants me to just do that.
Oh,
Why?
Because there is print inside.
it is still returning.
It's not, there is no return.
This guy has no return value. He's not returning the string in reverse. That's what we're going to do next. He's not returning the string in reverse. He just prints it out in reverse himself. So I was printing out something that doesn't return anything. All right, so we're just calling this method, and this method goes through and prints it in reverse, whenever I pass it. There's hello backwards.
Oh,
Okay? Now, the last thing that allows us to look at string concatenation let's say I have a method called reverse that takes a string as a parameter and returns a new string that is the original string backwards. Okay, so for right now, I'm just going to return the empty string so this doesn't give me an error. And I'm going to show you how string concatenation works up here. So I'll create my string s, set equal to hello. I'll print out whatever s is. So that'll print out hello. Then I'm going to set s equal to, this is the assignment operator, so whatever's on the left-hand side of that is receiving a new value. The value I'm going to set it equal to is whatever s currently is. Now, since I'm dealing with strings, the plus sign here is treated as a concatenation operator, not addition. So I'm taking s, I'm concatenating onto it a space, the string representation of a space, which that whole thing then boils down to hello with a space after it. Then I'm concatenating onto that the string world. So this will print out hello and then hello world. This allows me to build strings. The concatenation operator allows me to glue strings together. Now, an interesting statement here, which is Java is a string-based language. Generally, this means that if you can get something as a string, you can do nearly anything with it. How do I turn I into a string?
Char.
You do.
So I have a variable named I here. Here, we'll do. Let's do it as a method. Static string int to string. So I want to write a method here. This method takes an int as a parameter and returns the string version of that int. So if I took in a 5, it should return the string 5. If I took in a 38, it should return the string 38. So on and so forth.
Change instead of char.
Change it to a char? Char is not a string.
Yeah, but you can add it to string like what you did there.
No, it's still good.
Content.
I wasn't dealing with any chars up here. These were all strings.
Yeah, but like
Content.
container between them, like
That won't change it into a string.
like s equal I.
What letter would 5 turn into? What letter are you thinking 5 would turn into?
Well, I don't want the character version of I.
Okay.
If I holds the number 5, I want to store the string that has 5 in it. So the int 5 should become the string 5. That's what this guy should produce.
Then don't string C equal I.
What is this guy? Double quote, double quote. It's called the empty string. The empty string is the string containing 0 characters. But the most important thing is it is still a string. So since that guy's a string, what is this operator? The concatenation operator, not the addition operator. It's concatenation. So if I take the empty string and I concatenate onto it an int, what am I going to get?
I.
I'm going to get a string containing that int. Now you might look at this and say, okay, wait a minute. What kind of dumb trick is this? They both look the same.
5. Integer 5. Second
One is an
5.
int.
Well, how do we know that this one's a string and this one's an int?
Try to do
Ah,
math
no,
with the
what-
string.
Oh, that's not a bad idea. We could try to do math. So I can say I plus 10 there. And then I can take whatever this guy returns and add 10 to that too. The first one's going to give me a 15. The second one's going to give me what?
5 plus 10.
5 plus 10.
Which is
Concatenation.
5, 1, 0.
Yeah.
That make sense?
Yeah.
I also could take the length of this guy because he's a string. So I can get the length, which is 1. I can put a bigger number in here and get the length of him, which is 6. Make sense how string concatenation works? Okay, so for your homework assignment, you're going to have to use quite a bit of string concatenation. So let me, I have to reveal this first. Access. So for the programming assignment, you're writing the following methods. First one is called print vowels. This method should take a string as a parameter and print all of the vowels contained in that string, 1 character per line. Next one is called print consonants. This method should take a string as a parameter and print all the consonants contained in that string, 1 character per line. Then print digits. So those 3 are all basically the same. Last one, process expression. This method should take a string in the format of some integer followed by plus, minus, times, divide, plus some other integer 0 or more times. Your method should then process the expression and return the result as an integer. You must solve this problem using only tools that were taught thus far in 535. So, for example, if you took in the expression that was just the string 125, you should boil down to 125. If you took in the string 125 plus 7, you should boil down to 132. 125 plus 7 minus 2 is 130. 125 times 2 is 250. 10 divided by 3 is 3. That make sense? So you are guaranteed to have at least 1 integer, but you might have 2 or more integers, each separated by an operator, either plus, minus, times, divide. And you have to process it like a calculator. Again, using only the tools you've learned in here so far. I'm emphasizing that. Because next week, when I show you the solution to this, The solution that you guys are going to have to come up with for this is going to be an absolute nightmare. And then I'm going to show you some new tools that would actually make it easy. So
Thanks a lot.
I'm trying to hold a smile. It's like I'm very sad about this too.
That can't work for you.
Okay, so that makes sense what I'm asking you there?
Yes.
All right. I need to unlock unit 2, I think.
Yes, that one.
Let me make sure this is unlocked. I know I already did it, but we're not sure it's necessarily. Okay, yeah, that's legit at this point. Actually, they may have all gotten unlocked. Is that how it works?
You can lock that one.
Can do it.
Oh, hold on. I want to see how this is actually working. Oh, that's dumb. All right. All right.
What is that one?
I have to do this. Change the access to no. To just me. At that level. That should have everything locked down inside. Then I'll unlock just this one.
Why don't you want to unlock everything?
Because I don't want you to see next week's homework.
That's not fair. Maybe we want to get a head start.
Yeah, but I don't want to. I have to look next week to see what I'm supposed to teach you.
At least on the paper, man.
You were complaining that one paper is too much for a week.
That's why we want to get a head start on the second one.
So you're
we
saying
know
what you
that
really
one-
want to do is you want to do 2 papers and a
No.
programming assignment this week.
No. What I'm saying is still have the other one due the week after when it's supposed to be due. But I'm saying it's probably gonna be just as dumb. So we're gonna need some extra time.
But you're already saying you don't have enough time to do one of them.
That's the problem. That's why we need to
So
get
even-
a head
Yeah, but so even if I give you,
So give us both, and then we get 2 weeks to do. Never mind. Just leave it as is. Cause you.
what is this one? Oh, let's see how bad this is.
Oh Lord, don't scare me like this.
Write a 3 to 5 page paper discussing problem solving as it is related to technology. Specifically discuss when it is appropriate to use existing tools like Excel to solve problems versus writing your own software to solve a problem. Using the right tool for the job is a large part of being a successful IT professional.
That's not too.
We learned that with the Excel.
Hey,
That
hey,
seem-
hey!
that
don't
seems this
tell
seems
us.
more legit.
Yes.
So I should change it.
No.
No.
All right, questions about anything? Make sense? Everybody understands what I'm asking for the homework?
Yeah, I guess.
All right, I'll see everybody next week.